Okay, everybody, Lego Batman review. I'm gonna do a little go over of 1, 5, and 7. Number 1 I just did, just to get you started. You got Lego Batman, you have to do the conversion from 22 kilometers per hour to 6.1. You divide by 3.6 because you're multiplying by 1,000 meters, dividing by 3,600 seconds. So the trick is, that's actually the same as dividing by 3.6. So we do those conversions for both of our velocities. And we know the time. We put that into our first formula, which we manipulate to solve for acceleration. And we get an acceleration of 3.5 meters per second squared. It's coincidence that that number is the same as the time. I didn't mean for it to be, it just is. Okay, that's number 1. Now number 5 is the cannon with Curious George, right? Yeah. Am I right about that? Yeah. Okay. I love Curious George. Don't think poorly of me. He was a good little monkey. Always very
Why
curious.
is that past tense?
He's immortal.
Oh yeah, that's dark. He is a good little monkey. Always very curious. Can somebody tell me the values for number 5?
What do you mean by values?
What are the numbers?
VI is 65.
VI is 65.
Displacement is 212.
Now, up and down matters in this one, right?
Yes.
Now he's always traveling down.
Yes.
We're launching him downwards
Okay.
in this one, if that's confusing, which is not the normal situation, but it's handy to know how to do this. Does he ever travel upwards in this problem? No, so if you wanted to, you could just say down is positive and just keep everything positive the whole way through. That's fine. If you're a purist and you're like, no, down is negative, always. Then you can make them all negative. Which one would you like me to do? Negative? Who says like, no, down is negative, always keep it negative? Who says, no, we're gonna make up positive? Only a couple. Okay, so I'm gonna do negative. You can keep these numbers all positive, it will come out the same. So we shoot him downwards at 65 meters per second. What else do we know?
Wait, I have a question.
He's on a cliff, right? So we're shooting him out of the cannon this way. He starts at 65. He's going. Now, in the real world, Curious George is going to slow down right away, right? Why? Air resistance. But in the land of Physics 11, there's no air here, which is fine for Curious George. And he's going to continue to increase speed, right? If he did this on the moon, this would actually happen. He would shoot out at 65 and he would keep speeding up all the way to the ground. His acceleration would be what?
Negative.
Yeah, on the moon it would be different, so don't get confused with that. But here on Earth, negative
Wait, I have one
9.8. If we did this in a big vacuum chamber, he would continue accelerating downwards at 9.8 meters per second every second. Yes, Izzy?
If we did like everything positive, does that mean our acceleration needs to be positive?
Yes, that is correct. If you do everything positive, the VI is positive, the acceleration is positive, and the displacement is positive. If you say down is negative, all of these are downwards, so the displacement must be negative as well. He's going to end up lower than where he started, and that's 212 meters. Now we're looking for his final velocity when he hits the ground. So we're saying VF equals what? So we can just use our first formula, our second formula. And we're going to solve that for VF. You could also, no, this is probably the best way. I'm just going to write it out like that. And then we put our numbers in and we go negative 65. Now if your velocity is negative 65 and you're squaring it, I would put that in brackets because the negative is going to disappear. And then you have 2 times negative 9.8 times negative 212. Sorry, you can't see that. That's negative 212. and those two negatives are going to cancel each other out. So this is going to end up all positive underneath our root sign. So in the end, it doesn't matter if you use negatives or positives. They just all have to be the same. We got to square root this all. If you calculate that all out, I haven't done it yet. What do you get?
4,225
That's handy. 4,225?
plus 4,155.2.
What's the final answer?
91.5.
91.5?
Yes.
Yeah.
That makes sense. I'll just leave it at
Wait, doesn't it have to
91.5.
be negative 91.5 then?
Yeah, this, so there's a little bit of a trick here, right? Because no matter whether you use positives or negatives, you're gonna end up with this all positive under my square root sign. Remember, when you find the answer to a square root, it can be positive or negative. You guys understand that?
Yeah.
Yes.
So what's the square root of 16?
4 or negative 4.
4 or negative 4. Negative 4 times negative 4 is also positive 16, right? So this is plus or minus 91.5. And we just say, well, we're shooting him downwards, so we know it's going to be negative, right? And if you did all positives, then this would be positive, but it's still downwards. Okay. That's number 5. Number 7, and I'm gonna erase this, but you can
Can
go
we
back.
do 6 too?
Oh, really?
Yeah.
What's number 6?
That's the first.
Can I just tell you how to do number 6?
I
Or
just
do you want to actually? Who wants number 6 as well?
Why not?
A couple. Number 6. What's number 6? Oh, actually, this is important.
See?
We happen to have a basketball right here. Oh, is this yours? Oh, you can have one.
Yeah, go for it.
Thank you. I used to always have a basketball in class. I don't know if you can see this on the video. Can they see this? Okay, well, trust me, the ball's bouncing on the table. When the ball hits the surface of the table and it bounces up, does it contact the surface for any amount of time?
Yeah.
Or is it just like a single instant of time?
It's only for like an instant.
We'll see if this works. Watch really carefully. Did it take any amount of time?
Yes.
If we did a slow-mo video, would we be able to see the ball contact
Yes.
the surface and leave?
Yeah.
Yes. The ball is in contact with the surface for an amount of time. It looks like it's no time, but it does take some amount of time. What's happening to the ball while it's touching the table? It's compressing down and springing back up, right? You don't have to know this yet, but in order for the ball to go back up, there must be a force on the ball pushing up, right? What's providing that force?
The force that we with the hammer.
It's got to be the table, right?
Oh,
If
it's
this
one of the
tabletop was
Newton's laws,
floating,
actually.
would the ball bounce up if
Yes.
the tabletop was floating?
Yeah.
A little bit, but not as much probably. What would the tabletop do? It would get pushed down, right? Again, I'm going a little bit ahead here, but the force pushing the ball up is the same as
That's
the
the force
force.
that is pushing the ball that is pushing the floor actually.
Good. And what's the table attached to? The earth, right?
Yes.
So, does the earth move when I bounce a basketball?
It's the third Newton's law actually.
Yeah, we'll get into that later, and that's very good of you. Okay, so when you bounce the ball, if you're looking at the bounce part, not the fall, not the throw, but the actual bounce while the ball is in contact with the table, is the VI up or down?
VI is down.
Right. It hits the table moving downwards. What's the VF?
Up.
Up.
Minus.
So you have to decide whether up is positive and down is negative, or if up is negative and down is positive. Either way is fine. Doesn't matter. They just have to be opposite. The final velocity is up. The initial velocity is down. And that takes some amount of time. Yes. You can see this if you get one of those big dodgeball balls, you know, like in gym you have those like, and they like, you know. I should go and get one of those and show you guys. The rest is just simple kinematics. You just do the VF minus VI divided by time, yeah, and you're gonna get your acceleration. Is the acceleration gonna be 9.8?
I got -96.
Good.
I got -60. Yeah.
It should be about 90. It should be over 90.
I got negative 96.
You got it? You got it figured out?
It's negative though, right?
Now, what does the negative mean? Up or down?
Down.
When you hit the
It's up.
When you hit the surface, the ball is going to squish and get pushed up, right? So you're going from a downward velocity to an upward velocity.
Oh, so it should be positive.
So your acceleration should be upwards. Now, Izzy, it depends on what you called positive and negative.
I did VF as positive. So then my
Okay, so your answer should be positive then. And it's high, right? It's a lot bigger than gravity. And that's because this change in velocity takes very little time. So it's a high acceleration. Okay, 90 is totally normal. Thank you, Thomas. Thank you, sir. Number seven.
Oh,
That was number 6. Here's number 7. Pardon me? Oh, thank you very much. Okay, number 7 is an interesting one too. You grab a Beanie Boo and chuck it straight up. A Beanie Boo? You guys don't know Beanie Boos? They're little things that like people collected for a while. I don't know. And the VI equals 42 upwards. And then I ask you, at what 2 times is its displacement 22 meters? So if you draw a line somewhere on this parabola, there's going to be 2 times that it's at the same height, right? It's moving up here, and then later, it's moving down. Okay. What would you tell me about the velocities at these 2 spots? Good. One's moving up, and one's moving down. What about their numbers?
They're going to be the same.
It's going to be the same number, right? So if this is a 10 up, this is going to be 10 down. We have to solve for that. And I'll show you the math of why this works. So we're going to use, the first step is to find VF. Okay, and we're going to use the second formula for that. And in order to solve for the final velocity, we have to take the square root of everything else, right?
Yeah.
When you find a square root, what do you know about the answer? Plus or minus. So it's going to be the same number, but it can be positive moving up or negative moving down. If you calculate that out, that's going to be 42 squared plus, this is going to be 42, and that's going to be negative 9.8, and our displacement is going to be 22, right? So you're going to get a negative number, but the 42 squared is going to be bigger, so we're still going to have positive. And when we square root it, we're going to get, can someone tell me the answer for that?
36.5.
36?
When we square.
We'll say 36.5. And then that's my final velocity. Is this answer correct?
No.
It's not complete, right?
Complete, yeah.
It could be positive or
Minus.
it could be 36. So this is on the way up, this is on the way down. So now you plug these two velocities into the first formula to find our time. Okay, and so we go VF equals VI plus AT, and we solve that for time. We go VF minus VI over A equals time. And so first of all, we're going 36.5 minus, our initial is 42, right? And negative 9.8. And you're going to get, what is that? 0.7 or something? 0.56 seconds. But then we do it again, right? And we do negative 36.5 minus 42. And this one's going to be a lot bigger.
8 seconds.
8?
Yes.
And this is somewhere around 8 seconds.
Exactly.
So this is the time it takes to get to 22 going up. And then it's going to go way up and come all the way down. And then it hits 22 again, 8 seconds later.
Wait, why would it be like a longer time going down?
Okay, so
Or is it
imagine
because
this
it has
is,
to go, is it because it has to go up and then down again?
right?
Yeah.
It goes up here, and then goes all the way up, it's all the way down, and now you hit moving down again. But this happens later, right? So this is actually a really high, it would go like way high up there, and then all the way down.
This is a really good question.
Yeah, I think so too. If you can do that Lego Batman review, and it all makes sense, you're going to be really good for the quiz on Friday. I'll see you then. If you have more questions, come to X Block on Thursday.
Sure.